All right, guys, we are on the back side of day 2 notes for Unit 9. And we have a few more systems to solve like we had on the front, okay? So it says algebraically solve the following systems of equations. Remember that there are 2 equations and you have to find 2 variables, okay? Just like in the beginning of the year when we had 3 equations, we had 3 variables. We had to solve for all of them before we were finished. Okay. We're always going to use substitution with 2 equations that are not alike. For instance, the top one is a circle and the bottom one is a line. Okay, so we're going to have to get one of these equations into x equals or y equals, and make me a promise you'll never touch that circle to get it into x equals or y equals. Way too tricky. You will always go ahead and rearrange the line instead. Okay, so it's up to you if you want y equals or x equals. Right? It does not matter. They're probably about the same equal level of difficulty. We are more used to getting equations into y equals than x equals, so maybe we won't want to go that route, okay? So I'm going to go ahead and add 4x over, and I end up with 4y equal to a positive 4x, okay, plus 8. And then I'm going to go ahead and divide by 4 so that I now have y equals by myself, okay, or by itself. Okay, but everybody on the other side gets divided by 4, and therefore I end up with just x, and 8 divided by 4 is 2. Okay? And now what I can do is I can grab what y equals, go back to that first equation, erase my y there, and drop in the x plus 2. Okay? And so here we go. This is what it's going to look like. We're going to have our first part of the equation stay the same, x plus 1, all squared, connector, which is plus, parenthesis, and that x plus 2 is going to go in for the y, but watch out, there's still a minus 2, there's still a parenthesis, a squared, an equals, and a 25. Okay. We're just going to go ahead and clean that up a little bit in there. So this is going to stay x plus 1, all squared, plus, here we have positive 2 minus 2, which cancel each other out, and so we're just left with an x squared. In fact, we don't even need the parentheses since it's only one term now. Okay. So we'll just do that as x squared equals 25. Okay. We're going to go back here. If you want to use a box to expand this, you can, but x plus 1 all squared needs to be written out and put together. And when we put it together, guys, we're going to end up with an x squared, positive 1x, plus a positive 1x is positive 2x, and 1 times 1 is positive 1. A lot of people will write a 2 there. Be careful. Hey, I almost said 2. And then plus x squared. And you know what else I'm going to do? I'm going to bring over that 25 so that I'm equal to 0 because I can tell that I'm going to have squared terms, okay? In fact, I have an x squared here and an x squared here, so I actually have 2x squared. And then my plus 2x. And then I got my positive 1 minus 25, which is a negative 24, equal to 0. Okay? That is a hard trinomial. However, we can get out of it by pulling the 2 out and being left with x squared plus x minus 12 equals 0. All right, I'm going to move up a little bit. And what I have here is a nice easy trinomial. So off to the side, my x box, my multiply is negative 12, my add is 1. Okay, we're going to find the numbers to be 4 and 3, except the 3 is going to have to be negative, so that if I multiply those, I get negative 12, and if I add them, I get positive 1. Okay, so the 2 is going to stay here, my easy trinomial that I can give a happy face to. Woo! Okay, I can go right to my factors of x plus 4 and x minus 3 equal to 0. Okay, ready for t-chart since I can't factor anymore. Factor of 2 equaling 0, there's no x, so no solutions. But here there is an x, and x is going to equal negative 4. Here there's an x, and so x is going to equal positive 3. And remember not to stop there. Those are just your x values. We're solving a system, and there are 2 equations, so 2 variables. Up at the top, remember that we rearranged the equation to y equals x plus 2? We're going to use the rearranged equation versus the one that wasn't rearranged, the one that was given to us, just because this will be a little bit easier, but it does not matter which one you use, okay? But again, I would not use the circle equation to plug in. Always use the linear here to find your y values, okay? All right, so x is coming out, negative 4 is going in, and we're going to end up with y equals negative 4 plus 2, which is negative 2. We grab the x, grab the y, and pair them up. We end up with the intersection point of negative 4, comma, negative 2. Okay, here we take the x out, we put in the 3, and we end up with y equals 3 plus 2, which is 5. We grab the x, pair it with the y, and our other intersection point is 3, comma 5. And those are the 2 points of intersection that that circle and that line would have if we graph them and we could see it with our own eyes. Okay? All right, I'm going to go back up and we'll do the second one. Okay? Drawing a little separator line so our work doesn't get confused. And here we go. Okay? Top equation, guys, is a circle. Bottom equation is a line. Neither equation is y equals form or x equals form. And so we're going to grab the line and we're going to get it into x equals form or y equals form. It does not matter. Okay? You just have to be careful on who you substitute it in for. We are more used to getting equations into y equals, so we're going to go that route, okay? So I'm going to go ahead and subtract the 2x so that I have 2y equal to a negative 2x plus 10. Okay? I'm going to then go ahead and divide by 2 so that I end up with y equals negative 1x, okay, plus 5. And you really don't need that 1 there if you don't want it. You could just say negative x. It's up to you. You don't really need that 1 there. Okay. And now that we have y equals, we're going to grab what y equals, and we're going to drag it up into the top equation, and we're going to drop it right in for y. Now, if we solved for x, we would make sure that we drop it into the first one for x, okay? All right, we're ready to go ahead and rewrite this. Okay, so the first set of parentheses stays the same, x minus 3 all squared. Keep the plus sign connector, keep the parenthesis, and now drop that in. So that's negative x plus 5. But there's also a plus 2, then a parenthesis, then a squared, then an equals, then a 16. Okay, so make sure everything stays and you don't make anything disappear. Okay, we're going to go ahead and clean up in that second set of parentheses. Okay, that negative x is going to stay, but that's a positive 5 plus 2, which is a positive 7. And now we're going to go ahead and expand. So this is going to be an x minus 3 times an x minus 3. Keep the connector, a negative x plus 7, and a negative x plus 7 equal to a 16. Okay. Go ahead and distribute. So x times x is x squared. This is a minus 3x, and so is this, and so that's going to be a minus 6x. A negative 3 times a negative 3 is a positive 9. Keep the connector. Negative x times negative x is positive x squared. A lot of people mess that part up. Okay, that's a minus 7x, and so is this, and so that'll be a minus 14x. 7 times 7 is positive 49. And I'm going to bring over my 16 so that I'm equal to 0. All right, I got a lot of cleaning up here. Here we go. X squared and x squared is a 2x squared. A minus 6x and a minus 14x is a minus 20x. I got a positive 9 plus 49 minus 16. So 9 plus 49 minus 16 comes out to be a positive 42 equal to 0. Okay. This is a hard trinomial. However, again, like the last one, you can get out of it by pulling out a 2 and being left with an x squared minus 10x plus 21 equals 0. And now this nice easy trinomial off to the side, our multiply is 21. Our add is negative 10, and we're going to find it to be 7 and 3, but both have to be negative so that I get a positive 21 and I get the negative 10. Okay. I'm going to move this up a little bit so I can factor my nice easy trinomial, which we could give a nice happy face to. All right. And we're going to keep the 2 there, and the easy trinomial will factor into x minus 7 and x minus 3, and we are equal to 0. Okay. T-chart, since we're done factoring, the 2 does get equal to 0, but no x's in there, so no solutions come from that factor. But this factor will give us a solution of positive 7, and this factor will give us a solution of positive 3. Okay. Don't forget you had 2 equations, so you need 2 answers. Okay, so you need to solve for the x and the y. All right, and so here we go. We're going to go back up. Remember that equation that we rearranged off to the side there, y equals negative x plus 5? We're going to use that rearranged version, okay? Or you can use the original. It does not matter. It's just I think it's easier if you do this one, okay? And that x is going to come out and the 7 is going to go in, but be careful that negative is still there. So this is really y equals negative 7 plus 5, which is negative 2. Grab the x and pair it with the y and write it as a coordinate, which would be 7 comma negative 2. Okay. Do the same thing on the other side. Take the x out, put in the 3, but be careful. It's negative 3 plus 5, which is positive 2. Grab the x, pair it with the y, and we end up with positive 3, positive 2 as our second point of intersection. okay, for this circle and the line. All right, it is a very involved process. You have to be very careful. If you make a mistake, things are not going to work out how they're supposed to, okay? So if you end up with a trinomial, okay, that's not factorable, chances are somewhere along the way you made a mistake. So be very careful to try to go back and find it, okay? We got a couple more multiple choice questions down at the bottom that we'll use our calculator for, all right? In number 7, it says find to the nearest hundredth the smallest input value. Hopefully you guys know that input value is x equals. So on the front, they use the word solution to remind us that it was x equals. Here we put input value, okay, to be x equals. And this is not multiple choice, okay? So that's a little confusing on, do we have to use our calculator or are we supposed to be doing this algebraically? Notice it doesn't say algebraically, okay, but it is a little confusing, but we do have no way of solving these two systems, these two equations algebraically, just because x is your exponent there. All right, we would have to put that kind of into log form, and it would get really messy. All right, but we are going to use our calculator, okay? So we're going to go ahead and take our first equation, put it in for y equals, okay, or y1, and we'll take the second equation, put it into y2, okay? And then we'll go ahead and graph them. Be sure when you're entering in the first equation, guys, that 1/3 is in parentheses, and then it's raised to the x on the outside. For the second equation, negative x squared minus 5x plus 9 goes into our calculator. Now that my two equations are in our y equals, we'll hit graph, and we'll see if we can see the whole thing. And we can't see the whole thing, okay? We can tell that the one is a exponential decay, which is the first one. And the second one is a sad parabola, okay? It goes up and it comes back down. And we can see this intersection point, but we can't see the one up here that I know is happening, but we can't see it, all right? And we have to. So we're going to go ahead and we're going to hit window, and we're going to go to Y max, and we're going to change it, all right? So hit window, scroll down to Y max. Currently it's at 10, so I'm going to change it to 20 like I did on the front side of our notes. And I'm going to hit graph and see if it is good enough. And we just have to wait for it to graph to see if the change will help, and it does. I can now see both intersection points clearly, all right? Because they said the smallest input, the smallest x value is actually going to happen at this one, and I don't even care about this one. So I'm going to go and hit second, trace, and go down to intersect. And I'm going to get the cursor, and I'm going to move it to that intersection point that would have my smallest input, and I'm going to hit enter 1, 2, 3 times. Okay, and right at the bottom, it spits me my answer out, and it says that x equals negative 2.479995. They said to the nearest hundredth. Hundredth is the second decimal place. Look next door, and it's going to change it. And so we'll say our answer is x equals negative 2.48. And there's our answer. Okay. All right. Let's go ahead and take a look at the very last one. And in number 8, it looks like it gives us two equations, f of x and g of x. And they want to know an approximate solution for the equation f of x is equal to g of x. Okay. And again, because they're talking about solution, remember solution is what x equals. And just based on knowing that, I'm going to get rid of choice 3 and choice 4 because these look like they have y values where the first two are only one single value, okay? And because they said solution, solution is really only what x equals, okay? You would think that the solution is the whole point, but it's not, okay? So here we go. We're going to go back to y equals. We're going to clear out our equations from the 1 to 4, and we're going to type in 3. We're going to go second, 0 to go to our catalog to grab our absolute value. Type in x, hop out of the bars, and put minus 1. And we're going to go down to y2. And we're going to type in 0.03 x to the third minus x plus 1. And we're going to hit graph, and we're going to see if we can see the whole picture. And we can see, can we see all the intersection points? It's not clear that we can see that very last one. Okay, all the way to the right side, they're both going up, and the red one seems to be kind of curving, not in because it's still going towards the right, but I'm wondering if it still goes up there, and I can't see it. I'm already at Y max of 20, so I'm going to go ahead and change to maybe a Y max of 30. So I'm going to hit my window, and I'm going to go down to a Y max of 30 and see what I see. I'll sketch it out for you so you guys can see my picture, and hopefully it matches yours. So we have a big giant V, which is the absolute value graph. And it does look like they're going to connect. All right. But I actually don't know if I need to see more of the top of my graph or more of the right side. So I'm going to go back to window, guys. And I'm going to change my Y max to 20. I'm sorry, my X max to 20. My Y max is still at 30. Okay. So X max of 20, Y max of 30. And I'm going to see if I can see it now. Oh, so close, so close. All right, so I'm going to go back to window. I'm going to make one more change. I'm going to change that Y max. I'm going to change it to a 40 now. Okay, so my X max is at 20. My Y max is at 40. Those are the only two things I've changed. Okay, so X max is 20 and my Y max is 40. And I can see them cross again. Okay, so here's what my picture looks like. Okay, this one comes up, hits it, goes down, hits it, swoops below, and then hits it again. And this is what I was looking for right there. Okay, I want to make sure that I can see all my intersection points. Okay, and so it says an approximate solution for the equation. So we're looking for our x values. So because we've already deleted their choice 3 and choice 4, we're going to look at number 1 and number 2. Okay, because those are both positive x values, I'm not even going to worry about this x value here on that intersection point on the negative side there. Okay, I am going to worry about this one here and this one here. So I'm going to go ahead, second, trace, to go to my intersect command. Okay, I'm going to go down to that first, well, technically the center intersection, okay, but the first one on the positive x side. And as soon as I'm on that intersection, I'm going to hit enter 1, 2, 3 times. And right at the bottom, it tells me that this intersection is at 0.5, that's a 5, sorry, 009 ... Okay, comma my y, but again, we don't care about the y. And that is too small to be my either choice 1 answer or my choice 2 answer. So I'm wondering if it's that other intersection point. And if you remember from the question on the front, that last intersection point is usually the one that is out of our viewing when our calculator screen is normal, okay, without the window being changed. And so you can see that they typically ask about that one. All right, they really want you to think, oh, hey, there's another one out there. I bet that's the one they're asking about. Okay, so we're going to go second, trace, okay, to go back to the intersect, hit enter. Okay. Move your cursor that they give you to that very last intersection point that we were moving our window around so we could see. And now that we can see it, we can put our cursor on it and hit enter 1, 2, 3 times. And this intersection point out here is at 11.2883 ... And again, we don't care about the y value. And since these are to the nearest hundredth, you guys can see that the second spot underlined, that 8's going to round it up, and we end up with 11.29. And there it is, okay? Which is tricky because choice 4, if you thought it was the whole point as the solution, okay? Very, very tricky on how they word that, all right? Remember, solutions are what x equals and only x equals, okay? All right, hopefully that helps, and I will see you guys on the next day of notes.